law states that for every action, there is an equal and opposite reaction.
Wait, what does that even mean?
Well, Helen, let me show you some examples.
Well, you see, this is Alex, and Alex is very mad that he can no longer go to the Drake concert because of something Myrna did. So Alex, being the guy he is, decides to kick Myrna. And even though Alex is the one who exerts the force, he feels pain afterwards. Why is this, you may ask? As Newton's third law states, when Alex kicks a trash can, he exerts a force of 60 newtons. And the trash can also exerts an equal and opposite force of 60 newtons. This way. This is why Alex feels pain after kicking the trash can. Let's do a couple of more examples to help you understand better.
Now this bus is a classic example of Newton's third law of motion. First of all, let's look at the bus driver. Now the bus driver is sitting on the seat, clearly indicated by pink. But despite his heavy weight, the seat and the floor of the bus do not collapse. Why is that? Well, although the bus driver is exerting a force downwards upon the seat and the floor, with the help of gravity, of course, both of these objects are also reciprocating this force upwards, resulting in an F net of 0. Therefore, the forces are equal and the seat remains intact. Another example of the third law are the wheels on the bus. Now, as they're turning in this way, they're pushing on the ground in this direction. According to the third law, the ground is also pushing on the wheels this way. This allows the bus to propel forward. Now, the last example of the third law that we are going to show you today would be while driving down the road, let's say a bird flies into the windshield of the bus and makes quite an obvious mess in front of the face of our kind driver here. Now, although the bird hits the windshield and the windshield hits the bird, as we've seen countless times in real life situations, will hurt itself, splatter, and probably die. Now, since the bird is getting injured, which of the forces is greater? The force on the bus or the force on the bird? Well, careful, because even though the bird hurts itself in contrast to the windshield remaining intact, each force is the same size. The fact that the bird splatters only means that with its smaller mass, it is less able to withstand the larger acceleration resulting from the interaction.
Okay, so for many years, space travel was believed to be impossible because there was nothing that rockets could push off of in space in order to provide the propulsion necessary to accelerate. Well, this inability of rocket to provide momentum is because okay, so pretty much it's a common misconception that rockets are unable to accelerate in space. The fact is that rockets do accelerate, even though there's nothing for rockets to push off into space. But the fact is this, rockets are able to accelerate due to the fact that they burn fuel and push the gas in the direction opposite which they wish to accelerate.
So let's try to incorporate the concept of Newton's third law into application problem. So carts A and B, each with a spring bumper, are pressed towards each other. When the carts are released, the springs push the carts apart such that cart A accelerates at an acceleration of 0.87 meters per second squared, and cart B accelerates at 1.42 meters per second squared. Given that cart B has a mass of 1 kilogram, what is the mass of cart A? So as Newton's third law states, when they are released, the force that pushes cart A this way would be same and opposite force that pushes cart B this way. So the F net of A is equal to the F net of B. definite could also be written as mass times acceleration. So all we need to do is solve for mass of A. Which is equal to 1.63 kilograms.